possible to reduce this startup time to 10 or 15 minutes. Both VPMEM and TempFS are no-cost options. So VPM is basically memory reserved to store main data fragments. So you take some of the memory assigned to the LPAR and give it to this VPMEM. It continues after the restart of an LPAR, but it is cleared on the reboot of the frame. And TempFS is creating a temp file system that's directly linked to memory. It continues after the restart of the LPAR of HANA, but it is cleared with the reboot of the LPAR and obviously the reboot of the frame. There are a few downsides to VPMEM and TempFS, mainly that these methods add complexity and IBM's live partitionability will not work. Also, most HANA customers with large databases will when they have a planned downtime, they will likely choose HANA replication as their method or their preferred method to reduce the amount of downtime. Fast restart options certainly have a place in IBM Power. I just don't know if I see them being used in production. In the last slide, we talked about restrictions to using shared processor pool LPARs with HANA. You basically need to have good affinity. So good affinity would be having an equal amount of memory per node and an equal amount of CPUs per node. So we note on this slide that node 1 has 0 CPUs, yet it has 250 gigabytes of memory. The problem with this is that you'll have processes that are running or threads that are running on a CPU that have to get their memory from another node, and that's going to add latency and decrease the performance. So also note that older versions of Linux running in a shared processor pool mode often do not correctly or accurately show the CPU memory affinity. You might get all the CPUs in node 0, and then you'll see the memory kind of distributed to the other nodes. Dedicated LPARs have always shown the correct affinity values, and some of the newer Linux versions are also accurate. So it's usually a good idea to look at the affinity from using the HMC command line with the ls memopt command.
In the next several slides, I will share some of the experiences I've had working with IBM's HANA customers. I worked with a customer that was planning for a migration. They had over 1 million SAP iDocs to process and needed to improve the throughput. The customer could only get 14,000 iDocs per hour. After changing from a shared pool LPAR to dedicated and running memopt to fix the affinity, they saw this increase to 19,000 iDocs. So here was the interesting thing, is that we tried to repeat this performance change, going from shared pool to dedicated and back to shared pool, and they both now are at 19,000 iDocs. So our conclusion was that the shared pool mode inherited the good affinity of the dedicated mode. And so the performance difference was not necessarily a change going from shared pool to dedicated, but rather a change in the affinity of the LPAR. But 19,000 iDocs per hour was still not a good enough throughput. We found out that the real problem was that the SEA was maxed with regards to the number of packets per second. By using different VLANs, we could spread the workload to the SEA on the other VIO, and we increased the number of network buffers added with each additional VLAN. Finally, we saw the best performance by physically moving moving the physical Ethernet adapters to the database server, and that gave us 80,000 iDocs per hour. All customers that come off of Intel hardware and now run HANA on IBM Power, all of these customers love the flexibility of Power. Customers can change CPU and memory quickly and with little effort. You only have to restart HANA for it to see the changes. This is not the case in most Intel or scale-out environments. HANA on Power is very flexible. This customer was doing a data migration and needed about 4 times more CPU during the migration. And as you can see, they used that extra CPU. We can also see that the storage performed well with read and writes of more than 4 gigabytes per second. After the migration, they reduced their cores to 14. This customer embraced shared processor pool LPARs for HANA early on, even before it was actually supported. This Nmon graph looks like any other Power workload running in a shared pool environment. I was at another customer that was doing a data migration. This environment had over 20 application servers that were feeding the database as part of the migration. The application team complained about bad response time, and some on the team thought that the database server and the IBM E980 might be at fault. After checking the database server and the Power VM environment, the customer brought in their network vendor to look at the problem. The network switch was dropping a lot of packets, much more than is normal. The network vendor recognized that this was a networking problem and that network buffers in the switch were not optimized for the workload. He described it as being like a 16-lane freeway going down to 2 lanes, and the traffic jam caused the increased latency and dropped packets. When the network buffers were correctly allocated, latency improved and everyone was happy, and the migration was a success. This is a customer I visited that had migrated from Intel to Power for their HANA environment. So they went from a 7+1 scale-out environment with over 300 CPUs to a scale-up LPAR with only 40 cores. Their application performance did not really change that much. Some processes, some SQL statements were slower, some were faster. But what the customer loved in moving to Power was they decreased the number of environments they had to manage. Where before they had 8 nodes for production, 8 nodes for QA, and maybe 7 nodes for development, now they just had 3 LPARs. Instead of monthly or quarterly updates for each of those 22 Linux images, now they only had to maintain 3 images. This customer saw drastic performance improvement in going from Intel to Power. Their sales solution improved from 24% to 238% depending on the query. And in their supply chain management queries, they saw an even greater improvement. They actually didn't believe the 16x improvement they saw and ran that query several times. I talked to this customer just last year, and they have continued to grow and now are at 9 terabytes. The migration method to move from Intel scale-out to IBM Power scale-up is a backup and restore of the data. In these migrations, the reorganization or reorg process takes the longest amount of time by several multiples. After the restore to the new environment, the database needs to change from multiple indexes to a single index. As you can see from these 3 data points, the better the storage performance, the faster the reorganization. Also, the number of indexes has an impact on the reorg time, with more complexity increasing the time.